Thanks for tuning in to another video lesson by Mr. Stark. This one is about the law of signs, but specifically only about the ambiguous case. There will be some ambiguity here, be prepared. And this method is basically using side-side angle. Now you should remember in geometry class that is not a congruence theorem for triangles, side-side angle, and we are going to learn why that's the case today, because we're going to start creating triangles and it's not going to seem very obvious what triangle that we're creating. So I'm jumping right in with our given information here. So if you have documents from me, you could follow along. If not, you're just taking notes. And here goes. Given A equals 12, C equals 8, angle C equals 25 degrees. Well, what are we doing? Well, we're solving the triangle. We're sketching the triangle, we're solving every single side and every single angle for that triangle. So hold tight. Let's start with just the steps that we're going to do. Step 1, draw the angle first. How many angles are there? Just one. How many angles are there? Angle C equals 25 degrees. What else are we given about the angles? Absolutely nothing. We're given one angle, and this is side-side angle. Just one angle. I'll highlight this in the next page here. Step 2, check the height. It's possible that the triangle that we're working with is a right triangle, so we will use sine, set up an equation, and find out if the height communicates a right angle, right triangle. And the third step is simply to use the law of sines. I will caution you though, the law of sines in this particular case, we're solving for quite a bit of information, especially if we have two triangles that we're working with. Wait a second, two triangles. Oh my gosh. You'll see what I mean in just a moment. So let's start with the first piece of information, the fact that we have A equals 12, C equals 8, and angle C is 25. So step 1. Step 1 here. Okay, what does a 25 degree angle look like? Well, let's see. I'll try my best here. Try my best to sketch a 25 degree angle. That seems doable, about 25 degrees. So that, my friends, is called angle A. Let's double check here. Is that angle A? That's angle C, oh my goodness. Angle C is what that is, and I'll label that 25 degrees. Okay, superb. And now we could sketch the bottom of the triangle. That's fine, that's cool, that's great. Okay, so the black is obviously the ground, triangle resting on the ground. Notice how I went a little bit further than I thought maybe I need to. You'll see why in just a moment. A is 12, C is 8. Okay, because we sketched angle C, little c is opposite that angle. So the next thing that we'll sketch is A equals 12, or label, I should say. So A equals 12 is this side. And C equals 8 is going to be somewhere over here. We don't know if that's going to look like this, or straight down, or something like that. Or maybe all three. Okay, so then if that is big, little c over there, then this is big A down here. What do we sketch next? Aha, C equals 8. So a little note to self here, because A is 12, I'm kind of keeping this in my brain as this is 12 units. So I'd like to sketch C in such a way that, I don't know, it's less than 12, that's all I'm saying. Alright, so first I'm going to do this. Maybe C goes straight down. I have no idea. This is so ambiguous, I have no idea. Okay, so maybe it's 90 degrees. But I'm going to call that just the height of this triangle. Furthermore, maybe C is actually so short, maybe C only goes this far, so C is here, one of these things. I'm not sure which angle it is. So maybe C just dangles, and there's no triangle that can be made. Or maybe C goes this way. C equals 8. Or maybe C goes the other way. I'm not sure. I'm just not sure right now. This is so ambiguous. What is happening? C equals 8 over here. So now I could remove some of the stuff that I don't need over here. I might use that for workspace. And I'm going to erase this vertical piece up here. And what now? Well, let me double check. Step 1, draw angle first, then sides. Okay, the reason why I created this blue side and the red side on the situation is, again, because I'm not sure how big this angle is up here. And by the way, what is that angle called? It's called angle B. Now again, like the last video, we're not always going to be CBA or ABC. It could be C up here at the top. It's all based on the information that we're given. So now I'm going to relabel this stuff down below, and I'm going to call this A2, and I'm going to call this A1. So a little bit more complicated than the basic law of sines with angle, side, angle, and angle, angle, side. So if you're still a little bit confused right now, just stick with me. What we're about to do next is work with this H. So notice, check the height. So what I'm doing here is just removing anything unnecessary, and I just want to show you the right triangle that is used from this height H. Okay? So I'll just erase this B and rewrite this. Okay. So I'm going to check the height. That means that sine of 25 degrees is equal to H over 12. H over 12. That's just based on trigonometry that we already know. So that means H is equal to 12 sine 25, just solving for H. Okay? And when I punch that into my calculator using degree mode, I get the fact that H equals 5.07 or 5.1. But C equals 8. So what does this tell us? Well, I think it's pretty obvious what it tells us at this point. It just is communicating that it's not a right triangle. That based on the information that we're given, it's not a right triangle. Okay? But it's telling us a little bit more. Now, I'm going to summarize this in just a moment, but just listen to what I'll share with you here, is that because C is 8, well, let's pretend that C is 3 right now. If C was 3, it would be slightly shorter than H. It would reach out here, reach out here, reach out here, and it would just dangle that side C. But since C is 8, it's actually making it so that C must be drawn like this. It has to be at an angle to actually touch the ground, because H is only 5 units. So we know that it's not a right triangle, and it must be pushed to the left or to the right. Now we currently don't know how far it must be pushed to the left. It could be all the way over here, or it could be all the way over here. So based on that information, we have 3 situations always. We have the situation that if H equals C, we have a right triangle. And I'm going to say one right triangle. Okay? One right triangle. That's not what happened in this situation. For us, what happened is that H was less than C. H is less than C. That means we have 2 right triangles. Not 2 right triangles, I'm sorry. Just 2 triangles in general. Like a tent. And then I'll go back to that picture when I said if C were to dangle, that means H is larger than C. Like the first situation, 0 triangles. So it's kind of nice when we get 0 triangles, we're like, well, we can't do anything, so there's no calculations to do. But again, if H equals C, there's 1 triangle, and it's a right triangle. And if H is less than C, it's forcing us to have 2 triangles. So that's step 2, and then the rest is just calculations. I'm going to take you back to that original picture. And we have this situation here, and we're basically going to set up the calculations for the triangle that's created with the blue side and the triangle that's created with the red side. So let's start with the red triangle here. So let's say sine of A, so we don't know what the angle A is, but we do know that side A is 12. Side A is 12. Okay, great. That's our sort of solid information that we can use for this entire problem, the fact that we have little a is 12. sorry, that's not our solid information. This is our solid information. We know that angle C is 25 degrees and the opposite side is little c, which is 8. Okay, lovely. So that means that sine A is equal to 12 sine 25 divided by 8. And that means that sine A, when we punch that into the calculator in degree mode, we get 0.63. We leave that in our calculator, and then we press second sine. So second sine of that answer. So you shouldn't type that in. You could press second sine, second answer, which is the negative sign, as in the negative symbol on your calculator. And you will get this angle 39.3 degrees. Now, if you weren't sure if that's angle A2 or angle A1, which is over there that I just sketched, just by looking at this picture, you should tell that this is an acute angle. So that is 39.3 right there. The other thing you should know from this picture is the fact that this blue C and this red C are congruent. So that means this angle on the opposite side, inside that triangle, is also 39.3, isosceles triangle. And we could identify a little bit more information from this picture as I fix my visual here. If we know that this angle down here is 39.3 and the other one is 39.3, then we could figure out what this angle is up at the top. And I sketched that with 3 arcs because it's different. So 39.3 times, or plus 39.3 is 78.6. If we subtract that from 180, we get 101.4. So that angle up there is 101.4. Now, just to clarify, that I didn't do that for any specific reason. I just wanted to punch that in there. But this entire triangle is what we're trying to solve for. So that's actually not the angle we want. We want the angle that is this entire arc right there. So this entire thing. So we're going to try to find that other little piece. So we have a few more minutes to wrap this thing up, but I want to communicate also that this side down at the bottom, we would call this little b2. Okay, so we haven't really talked about the sides much, but that's little b2. So I'm going to transition to another picture. It's going to refresh here, and I'll set up a new set of values. And we're basically still in step 3. So if we were to solve for b2 now, so I'll write that as b2 just so we're kind of clear on that. So b2 over sine. Oh, bummer, bummer, bummer. Okay, we have to do one more thing. I just realized here is that we know that this angle is 25, this angle is 39, and so therefore we could find out this entire arc here for angle B. So angle B, which is the red triangle basically, so angle B is equal to 180 minus 25 plus 39. So that's sort of a simple calculation that I should have done already, but that means that angle B is equal to 116. But notice how special that calculation was just by using a little bit of geometry with the isosceles triangle before, so that one over there. We actually found out that this angle is 15 degrees, and I'll draw that in green because, not green, but blue, because it's sort of part of our blue obtuse triangle. So now we could actually solve for B2. So B2 over sine of 116 is equal to 8, which is our C value, over sine of 25. Okay, and so I'm not going to actually calculate this. We have 8 sine of 116 divided by sine of 25, and whatever that value is, I'm expecting it to be somewhere, in the range of 12, maybe a little bit bigger than 12, because this angle over here is 116, and if this is 39 opening up to 12, this 116 should open up to maybe 15 or something, just something larger than 12. Well, golly, I just decided to do it. It's about 17. So we are almost done solving for both of these triangles, and I want to just remind you that this sort of looks like a tent, especially the one previous with the right angle. I don't have it anymore, but it looks like a tent. So every time we do these types of problems, it's going to look like a tent. 2 triangles most of the time. Okay, so we haven't completely solved this triangle, but we've figured out most of the information. So the last few things here, now I want to bring your attention to this green and blue triangle. The only thing that we're missing here is angle A1, which is basically right here. And so A1 is the difference between 180 and the sum of 25 and 15, which we could have just probably done in our head. So that is 140. Now we take a pause and we look back at this window, this picture, and we think, wait a second, is that 140? Does that make sense? It does. That's an obtuse angle. And by the way, this 140 and 39, that should add up to 180, but it's just off slightly because I rounded. You might remember this is 39.3, and that therefore would have affected the 101, which affects the 15, which affects the 140. So for the most part, just a little rounding error. And so that brings us to the final piece of the puzzle. We have little a, we have big A 2 times, we have big B 2 times, we have little c. The only thing that we're missing is little b1. We even have big B2 on this bottom here. Okay, so I'll just set that up, b1 over sine of, what is the deal? Oh, look, okay, here's our angle here, 15 degrees. b1 over sine 15 is equal to, I don't know, I could use any information I want. Some of it's rounded, so that's unfortunate. 12 over sine of 140 is what I would use. And then I would solve for b in that particular case. Okay, so that was a little bit longer than I'd like, but there are quite a few steps in this particular process. I recommend if you didn't quite get all the pieces, you look back at earlier part of the video and you'll see and hear exactly what would be expected to work through each part of the situation. So just remember that there's either going to be 0 triangles, 1 triangle, or 2 triangles, just like I wrote right here. And most of the time when we work through the challenging ones, it's going to be 2 triangles. And we have to just keep track of each individual piece. So, appreciate you checking out this video and watching, learning with me. Bye-bye.